What's happening, everybody? It's your boy Creative. Go ahead, say it with me. We are back at it again to do what? To create something great. Now, I'm not going to hold you. I'm super excited what I have planned for y'all today. We're going to be actually going over the back test and actually running our vectorized back test, right? So if you haven't already, go ahead and smash that like and subscribe button. So those that are just joining us on this iteration of this video, a vectorized back test is a back test that uses NumPy and Panda array to compute all of the signals and return all at once, right? Across the entire data set. It's fast, it's super easy to build, and it's the most common type of backtest that I use. So an analogy would be, right, it's the whole race that is in your head before stepping on the track, right? So we're going to make sure that we're visualizing the whole race. We're running the whole race before we actually step on the track. There's also an event-driven backtest. This is a backtest that simulates the advancing bar by bar, firing the signal, and then fails as they would occur in the real time. This is the most realistic type of backtest, and it handles partial fills, slippage, and order type, and it's used by platforms like Quant Connect. It is slower to build, but it is closer to the live behavior. And most of our backtest is kind of I want to say middle ground between a vectorized and an event driven. Then there's also the for loop backtest. This is going to be the middle ground approach, right? That loops through the bars in Python and then uses object classes to track the states. This is more readable than vectorized, but more flexible than event driven. It's good for prototyping fleet strategies before committing to the full event driven system, right? So we made sure that we had all of the packages we needed for running our backtest. Now I actually want us to review the backtest, fam. Okay, not the agent, but the backtest. Thank you. You're awesome. Here we go. So this is going to be a super simple VWAP and volatility backtest that we're going to be using on SPY using the 1 minute chart, right? Let me go back here. This is going to be the 12 steps in the backtest. So what it's going to do, we're going to load the data. We're going to load the data using DuckDB, and it's going to read the Parquet files, right? And it's automatically going to handle the timestamp conversions, excuse me. Then we're going to compute VWAP, and VWAP is going to be the volume weighted price average, daily reset by group by, and then it's going to accumulate by the price volume and then the volume, right? And then we're going to generate the signal. We're going to go long if it closes above the VWAP. Then we're going to go short if it closes below the VWAP. And then we're going to lag it by 1 bar to make sure that there's no look ahead bias, right? Because if there's look ahead bias, then that taints your results. If that taints your results, then you have a strategy that really doesn't work, right? You're just creating on wheels, right? So the return is going to be the percentage change on the close. Then there's going to be the baseline strategy. That's going to be step 5. It's going to be the signal time of returns, no position sizing. And then the rolling volume is going to be the 20 bar standard deviation times the square root of the base per bar. And this is going to be annualized. Position sizing, then there's going to be step 8, volume targeting strat, right? And more on that in a little bit. And then step 9 is going to be, we're going to clean for any invalid or any numbers or figures, right, that is coming back at 0. And then what we're going to do is the performance, and the performance is going to look at the Sharpe ratio. And the Sharpe ratio is the risk adjusted returns, right? So it's annualized mean return divided by the annualized standard deviation. So what it does, it measures how much return we earn per unit of volatility. So the benchmark is that 1.0 equals the stock market average, right? Is good. We're barely viable. Anything between 1 and 2 is extremely good. And anything greater than the 2, you're looking at hedge fund levels for Sharpe ratio. I try to average anywhere between like 0.75 and 1.5, right? I'm not looking for anything higher than that because, again, I'm not a hedge fund. I'm not raising money. And these are my own personal strats that I'm using, right? Then we're going to have then it's the max drawdown. The max drawdown is from peak to trough, right? It lets us know how much money at one point in time that the strategy lose. Then it's also going to be the tear sheet. The tear sheet is coming from Quant Stats. This is going to be the full metrics and also the SPY benchmark. And what that SPY benchmark allows us to know is that if we just held SPY, right, and didn't do anything else, if we just held it, is the strategy more competitive than just being able to hold SPY? Then we're also going to have an equity curve. So As you can see here, we're importing DuckDB. We're also importing pandas as PD, right? And then NumPy as NP, QuantStats as QS, and then Matplotlib as PLT. Here's the configurations and the target volatility, right? Remember we talked about volatility targeting, right? Volatility targeting is a position sizing method that scales the trade inversely to the recent realized volatility. When volatility is high, we want to be able to size down, and when it's low, we want to size up. So we keep the risk constant across market regimes, and the formula is going to be positions equals target divided by the rolling volume. This was lagged by, and then we also want to lag it by 1 bar. This was created by Campbell Harvey et al. Right? I don't want to take anything for that. Want to also source it, and I'll also link the paper in the description. So this is for the volatility targeting, right? This is being able to load the data. We're going to compute VWAP, and this is how we're computing VWAP. And then step 3 is being able to have the signal with no look ahead bias, because we're going to lag by 1 bar to make sure that there's no look ahead bias. So what is a look ahead bias, right? You can't find the signal and then sometimes you can, but it's all depending on the strat. But you want to make sure that when the signal is fired on bar A, that you're not looking at bar B, right? That you're only at that point in time looking at bar A, right? So lagging by 1 bar, letting us know, or letting us make sure that we're not giving the strategy any advantages, right? We're not cheating or anything, right? So step 4 is going to be the return. Step 5 is going to be the strategy without volatility targeting. And then step 6 is going to be the rolling volatility. Then we're going to have the volatility targeting in A, the strategy with it, and then the performance. And then we have the full tear sheet. So let's go ahead and run our back test and see how well it performs. Now, one thing you have to notice here is that we have to bring in our conda environment, right? How do I know I'm not in the conda environment? Because it says base. So what I have to do is just drop in that conda environment. Now it says algo baby, bet I'm in it. Let's go copy the file. Clear, Python, and then run. So now we're actually going to run our back test. We're running our back test with Python because this is a Python-based back test. So as you can see here, it ran, and we have the benchmark, right? So the benchmark versus the strategy. So we have the strategy made 3.6%, but the benchmark was able to make 24%, right? The Sharpe ratio for the strategy is under 3.7, but the benchmark is 1.78, right? So there's a few things that we're going to need to adjust for this strategy. I just want to illustrate a point, right? We're not doing this, and it's not a strategy to actually trade. This is a strategy just to illustrate a point with regards to volatility targeting, right? Because as we can see here, before volatility targeting, we're looking at 0.33, but with it, the max drawdown went down a little bit lower, and then we also had a higher Sharpe ratio, right? Now what were we? Serotino, Omega, then max drawdown, right? Still a little bit aggressive, right? Then we have the monthly returns, 3-month returns. So as we can see here, let's go also look at the equity curve. So as we can see here, without volatility targeting, right? And what volatility targeting is, this is a position sizing method that can scale the trade inversely to recent realized volatility. So in other words, when volatility is high, we want to be able to size down. And when volatility is low, we want to size up, right? So it keeps risk constant across the market regimes. So we're seeing here without volatility targeting, even though the benchmark did beat the strategy both times, right? Your strategy over strat. That's not the point. The point is to be able to understand that volatility targeting does definitely have an impact, right? Without it, we're looking at a Sharpe ratio of 0.33, but with it, we're looking at a Sharpe ratio of 3.7. So what this lets me know is that if a strategy was actually viable, right, we could have it to be able not only beat the benchmark, but maybe even have a little bit more competitive Sharpe ratio. So I think this is a great stopping point in order for us to understand a little bit more with regards to backtest, right? Now, if you want more videos like this, I need you to go ahead and smash that like and subscribe button. It is your boy Creative. I'll be back at it again with another episode.